Hey, honors geometry students, welcome back. So if you are watching this video, I am gonna take a guess or make an assumption that you have an interest in reviewing for the Marking Period 3 progress check. So that is what I'm gonna be doing in this video and kind of prepping for it and some practice with it. So I do want to make sure that you're aware, and I'm sure that you are, that there are some things that are going to be in this video that realistically we haven't gotten to in class. And I don't want you to stress out about that or feel like, oh my gosh, I need to learn this stuff before the progress check. The progress check is not something that's going into your grade. It is not something that we are putting a lot of, or really any weight on. It is just something that we have to do kind of for data collection to see like where we are. And so it's completely fine that you haven't learned all of the skills. I'm going to go through this because I know that some of you guys want to be prepared, and we'll be able to pick up on some of these skills that we actually haven't learned quite yet in class. So you have access to this PowerPoint if you want to print it out or follow along and whatever you might need. So what might you see on the progress check? Right triangle trigonometry. We did tons and tons of this. So this, as I review it, yep, absolutely, something you learned in class. Area and volume. Now, we have been doing area, we haven't quite gotten to the point of volume. I want to emphasize another thing, that there is going to be a formula sheet. If this formula sheet has not already been shared with you, it is linked on the top of the weekly page. So like when you go to the weekly page and there's those shapes at the top that I can't think of what they, I think this is like generally what they look like, right? So it looks like this. The one all the way to the right, it got worse as I kept going, says formula sheet. Use it. You're going to see that all of these area formulas and all of these volume formulas are on there. So there's really, like, if you can kind of look at the formula sheet, and I'm going to show it in this video, and figure out what shape am I dealing with and what do I need to plug in, you're good to go. Okay. You're also going to see solids of rotation, which goes really, really closely with volume. We haven't quite done this, as well as cross sections. You've actually learned a little bit about cross sections, even if you don't fully realize it, because we learned about circles. So maybe your teacher mentioned the word conic sections. So you've learned pretty intensely, like more than some cross sections that we would learn about, you've learned about circles. Okay, so I will briefly review or talk about what cross sections are. So let's start with right triangle trigonometry. So this was sine, cosine, and tangent, right? Those were the three that we learned. And these were the ratios that we learned. These two on your formula sheet. So don't stress yourself out being like, oh my goodness, I forgot what those were. You also had a nice acronym, right? Remember SOHCAHTOA? And here's an image of what that looks like. So you have a reference angle, and sine is the ratio of opposite to hypotenuse. Cosine is the ratio of adjacent to hypotenuse. Tangent is the ratio of opposite to adjacent. So it's ratios of sides of a right triangle. And remember, like the two that switch are opposite and adjacent. Hypotenuse doesn't change no matter what the perspective is. So you want to look for what is your reference angle. And of course, we had our favorite, the Pythagorean theorem. So given two sides, we can calculate the third side, right? So I could do 5 squared plus 12 squared. I feel like we've still been doing this, right? So 25 plus 144 is c squared. 169 is c squared, and then we take the square root. And now we have some skills that if you don't take a square root, if it can't be simplified, instead of turning to your calculator, you would reduce or simplify the radical, right? So we've done a lot of work with that. Okay, and this is also on your formula sheet. So I would look at that formula sheet. So let's do some examples. So I've got this triangle, and I'm asked to identify the ratios, right? That's all I'm doing here. So the first thing that I notice is, oh boy, I'm missing this side. But I have a skill for this. I can use the Pythagorean theorem. I'm missing the hypotenuse, so I'm missing c. So that's 16 plus 49 equals c squared. That's going to give me 64? No. Yeah, right? Is that right? I'm not convinced that's right. 49 and 16. I'm not sure why I'm having a moment right now, guys. That's a 5. 65. I was like, this doesn't work out evenly. And then I will go ahead and take the square root of it. I am not going to put that into my calculator. If I tried to simplify that, 65 is 5 times what? 13? Oh, they're both prime. So I'm going to leave this and say this side is the square root of 65. Please don't give us a decimal. Just leave radicals when you experience them, when you come across them. It's called exact. So the sign of A, right? Let's go back to our old friend, this acronym. The sign of A is opposite. So here's my reference angle right now. Opposite 7 over hypotenuse root 65. You can rationalize if you'd like, right? Some of you guys might be saying 7 root 65 over 65. Either one is fine. The cosine of A is the adjacent over hypotenuse. So 4 over root 65. Or you might be saying 4 root 65 over 65 if you rationalize. The tangent of A is opposite over adjacent, so 7 over 4. Well, now in the second row, we're changing our perspective. Now I'm going to move and I'm going to be standing over here. Okay, so remember opposite and adjacent switch. So that now the sign of B is opposite over adjacent. It's going to be opposite over hypotenuse, 4 over root 65. Or 4 root 65 over 65. Right? These two were the same. The cosine of B is going to be adjacent over hypotenuse, 7 over root 65, or 7 root 65 over 65. And finally, the tangent of B is going to be opposite over adjacent, so 4 over 7. Okay? Take a look at number 2. So your friend is 5.5 feet tall. At noon, her shadow is 7.2, their shadow, is 7.2 feet long. What is the angle of elevation from the tip of their shadow to the top of their head? So let's draw a picture. Here's your friend. And here's your friend's shadow. Your friend is 5.5 feet tall. Their shadow is 7.2 feet long. What is the angle of elevation? Remember, that's the angle looking up from the tip of their shadow to the top of their head. So what is this angle? Right? So if you remember, when we're trying to find an angle, we have to use inverse trig. So I want to know, which sides do I have in relation to theta? I have opposite and I have adjacent. So I'm going to be using, ding, 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 tangent. The tangent of theta equals 5.5 over 7.2. And just like you know how to solve equations, we're going to do the tangent inverse to get rid of it on both sides. All right, keep it balanced. That cancels. Theta equals to the tangent inverse of 5.5 over 7.2. I don't have a calculator. All right, found my calculator. So remember, you push tangent inverse of 5.5 over 7.2. Make sure you're in degree mode. And I got that theta equals to 37.376 degrees. If you're rounding to the whole number, 37 degrees. Okay, so that was some trig review for you. The next topic is area and volume. And so I just screenshotted. I just took a picture of the formula sheet to show you what you have. So this stuff is the stuff that we've been doing recently, right? All of this stuff with area. Volume, you haven't quite done, but you can see it's broken into 3 categories. We have a prism, we have a pyramid, and we have a sphere. Well, density separate, so just worry about these. And so then it even tells you volume equals big V times H. Well, what does that mean? Area of base, oh, I've been learning about area, times height. That's what takes it into the 3rd dimension, the height, right? And then for a pyramid, which includes a cone, it's 1/3 area of the base times the height, right? So if you have a cylinder and a cone that have the same base, well, the cone's just going to be 1/3 of its volume. Same base, same height. So the difference between a prism and a pyramid is a prism has 2 bases, and a pyramid or a cone has 1 base, 2 bases that are congruent and parallel, has 1 base and an ape and I'm going to use the word an apex, like a vertex at the top where like all of the lateral faces is what they're called, kind of come together. And then a sphere, it's like a 3D circle, right? And really the only thing that we need to know is r. So it's 4/3 pi r cubed. And anytime pi comes up, let's leave it in terms of pi. Okay, so find the volume. Well, here I have a cylinder, which is the same thing as a prism, right? There's 2 bases, they're circles, you can see them. There's my base, there's my base. They're congruent and parallel, so this would act like a prism. So its volume equals area of the base times the height. The height is the distance between the 2 bases, okay? So I like to go off on the side kind of and say, okay, area of the base. Well, it's a circle, so pi r squared. So pi times the radius is 7, right? That's the diameter, 7 squared. So I get 49 pi is big B. And the height, the distance between them is 10. So the volume is going to be 49 pi times 10. So 490 pi, let's not forget our units, centimeters cubed, because now it's 3-dimensional. Volume is cubed. Okay? What about this one? So it says if the volume is 160 feet, oh goodness, cubed, sorry about that. Find the height. Oof, don't worry, we can do this. So this is a cone which acts just like a pyramid, right? In a pyramid, the volume is going to equal to 1/3 area of the base times the height. So let's see what I have. So I know that the volume is 160. Can I figure out big B? I can. It's a circle, right? Here's my base, and then you see how this is called the apex. So it's a circle, so pi r squared, pi times 5 squared, so 25 pi. So height is what I don't know. That's what it's telling me to find. So volume, well, goodness. I'm just going to plug in. I'm going to do some substitution. So volume is 160 equals to 1/3 times B is 25 pi times the height. And that's what I'm trying to find, that height. Right? This is what's missing. That's what I'm going to solve for. So I'm going to do this in pieces. I'm going to multiply both sides by 3 to get rid of that fraction. So when I do 160 times 3, I get 480 equals 25 pi times h. This is what I'm trying to solve for. 25 pi is just a number. Let's just divide by it. So the height is 480 over 25 pi. Yes, it looks weird. Feet. I can simplify that a little, right? 480 divided by 25 is 19.2, or I could say it's 96 over 5 pi. I need to remember the pi goes in the denominator, feet. And now it's just height, so it's just one-dimensional. It's just feet. Or I could even say 19.2 over pi feet, right? Leave it in terms of pi. Okay, what about this next one? So now we're trying to find the volume. So again, I have a cone, which acts just like a pyramid. So volume is area of the base times the height, 1/3 area of the base times the height. So I don't have the volume, that's what I'm trying to find. Area of the base is pi r squared. It's a circle. So pi times 10 squared equals 100 pi. So if I'm trying to find the volume, I must have the height, but I don't see it. Shoot. Does anyone see it? It's a right triangle, right? The height has to be perpendicular to the base. This is called the slant height, if you want a word for it. And I have this right triangle. So let's go ahead and use Pythagorean theorem. 10 squared plus h squared equals 13 squared. 100 plus h squared equals 169. So h squared equals 69, and the square root. It's not a perfect square, so let's just leave it. Okay? So volume equals 1/3 times 100 pi times the square root of 69. You can't really do too much with that, right? I think I'm going to say the volume equals to 100 root 69 pi over 3. What's the units? Oh, it doesn't tell me. So units cubed. That's all I got for you. Right? No, I don't even need a calculator. I don't want a decimal. I want an exact volume. I want to know exactly how much space is taken up. So what's interesting is if instead I gave you a cylinder, and the cylinder has a radius of 10 and a height of the square root of 69, the volume is going to be 3 times that, right? 100 root 69 pi units cubed would have been the volume of this, right? So just think about that relationship. And then let's look at this last one. We're finding the volume. Well, what is this? This is a triangular prism. I have two bases that are parallel and congruent. It's a little hard to see, but here's one of my bases. It's just on its side, right? It's not sitting, the base doesn't always have to be the bottom. So here's the bases. So sometimes I like to locate those first and then recognize that, oh, and then the height is the distance between them, right? So I know that I'm dealing with a triangular prism. So volume is going to equal to area of the base times the height. Area of the base, it's a triangle. 6 times 10 divided by 2. Base times height divided by 2 is 30. And then the height is 17. So volume would equal to 30 times 17, which equals 510 feet cubed. Okay? So use that formula sheet. Leave things exact. So now we've got solids of rotations. Now we're really getting into some stuff we didn't actually talk about. Sorry, y'all. So here's an example of a solid of rotation. So it's a 2D shape, like a triangle or a rectangle that's on a coordinate grid. And it's like you're spinning it around an axis. And you're looking at like kind of like the net of it. Like what space does it take up? So here, if I had a triangle and I spun it around, you know, if you spin something really fast, it looks like it's staying in that place. That's kind of like what's happening here. Or here's an example. All right, so you can see I had this triangle. It spun around the vertical axis, and this resulted in a cone. But if you're spinning, you can kind of picture what's happening. So what it allows me to then do is I could see, well, what's the volume, right? If I spun this, if here's my axis, I know the radius and I know the height, and I know that it's a cone. I'm never really going to get something with hard edges because it's spinning. So you're really going to end up with combinations of cylinders and cones. There's a website linked, I'll show you briefly, where if you're having trouble picturing it, you can play around with it for a little. So here I can say I'm gonna create something, right? So 0, 0, 5, 0, 5, 10, and then 0, 10. And I can push graph, and I can see what I have, and then I can pick what I want to rotate it around. If I want to rotate it around the x-axis, I should have this selected, and then I can push revolve, and I'll see what happens when it spins, right? And then you can kind of move it around to see what solid was created. So that's there for you to play around with. So if I rotate this rectangle around the y-axis, well, it's going to spin. You got to pay attention to like the size of it, kind of. I like to sketch it out. And I'm going to get a cylinder, right? My cylinder is going to have a radius of 1, 2, 3, and a height of 1, 2, 3, 4, 5, right? And so I could say, okay, volume is area of the base times the height. Area of the base is pi times 3 squared, and the height is 5. So the volume is going to be 9 pi, that's what this is, times 5. So I would have 45 pi units cubed would be this volume. If I chose to spin around the other axis, it's probably going to take up a different amount of space. What about this one? If I rotate this triangle around the x-axis, okay, so think about this point spinning down. So this is going to be 1, 2, 3, 4. So it's going to spin. I'm hoping I got the right distance there, right? And then this point isn't going to move. It's stuck to it, right? So I'm going to get like this cone with a radius of 1, 2, 3, 4, and the height 1, 2. So I get a cone. So the volume is 1/3 area of the base times the height. It acts like a pyramid. Area of the base, it's a circle, pi times 4 squared. So 16 pi, and then the height is 2. So volume equals 16 pi, 1/3, 16 pi times 2. So volume equals 32 pi over 3. Just leave the fraction. Units cubed. Okay? So it's kind of just like an extension on volume. Solids of rotation. You realistically, if you rotate a triangle, you're going to get a cone. If you rotate a rectangle, you're going to get a cylinder. And those are really the key ones. And then finally, cross sections, which you've learned a little bit about. So a cross section is the shape we get when cutting straight through an object. It's like a view inside to something made by cutting through it, right? So it's like I cut it open and I'm looking at what is the flat surface that I'm looking at. So cross sections are 2D, right? So like I can't get a cross section that's a cone, or a cross section that's a cylinder, or a cross section that's a rectangular prism. Like my cross sections are going to be like square, circle, parabola, ellipse, trapezoid, triangle. Like those are cross sections. It's the flat surface you're looking at. So for instance, like this is what you're really doing. Like if I chop off the top of this, I'm going to be looking at, well, it depends if it's parallel to the base and the base is a square, I'm going to be looking at a square. Here, I'm going to be looking at a square. Here, I'm going to be looking at a pentagon. Oh, I'm going to be looking at a triangle, right? So I'm going to be looking at a circle. Like, what is the flat surface? Like, I open it up and then I look at the new face, right? So, like, here's my cross section of celery. Okay. Thought I had something linked here. Do I not? Okay, sorry guys. So what is the cross section created when this pentagonal prism, pentagon, is cut parallel to its base? It's cut parallel to its base. Well, I'm going to be looking at a pentagon. It's like you're just chopping off its top, right? So it's like I open it up and this is the shape I'm going to be looking at. What is the cross section created when this cylinder is cut perpendicular? Well, you can kind of see it. When you take a cylinder and I cut it in half, think about like what just happened when we did rotations. What did you rotate to get a cylinder? Oh, that's like this right now. Okay, I'm going to end up with a rectangle, right? Oops, sorry. Didn't mean to cross that. I meant to underline it for emphasis. All right, y'all. So this concludes your practice and prep for the progress check. Hopefully this was a helpful resource. And again, please don't stress the progress check. It is not something that has weight to it. It's kind of just like a check-in to see where we all are. And it's okay that we haven't really gotten to all of these skills. We will, and that will be coming soon. So thanks everyone for watching. And if you've got questions, reach out and we'll see you next time.